This video teaches you how to use Python code to calculate value at risk with the historical method. I'll teach you how to do it with the keyboard and keep my use of the mouse to a minimum. Like this video, subscribe to this channel, buy my books, links in the description below. Let's get into this phenomenal video. To open Google Chrome, press Windows key, D as in Delta, arrow down, press enter, Alt E as in Echo, B as in Bravo to pull up the bookmarks, End key, and then press enter to get to Google Colorboard Toy Notebook. Tab over to get to value at risk historical method. The first thing we're going to do is import a bunch of libraries needed to run this code. Pip install Y Finance, which is Yahoo Finance. Import Y as in Yankee Finance as Y as in Yankee, F as in Foxtrot. Import the pandas data frame as P as in Papa, D as in Delta. Import NumPy as N as in November, P as in Papa. From SciPy decimal stats, import norm. Import matplotlib decimal pyplot as P as in Papa, L as in Lima, T as in Tango. Import Seaborn as S as in Sierra, N as in November, S as in Sierra. Import datetime as D as in Delta, T as in Tango. Import pandas underscore data reader as P as in Papa, D as in Delta, R as in Romeo. We're going to make the percentage matplotlib inline. And then for Seaborn, set the style to white grid. I want the figure size to be 16 by 8. DPIs are going to be equal to 90. The font, I want the sans serif family font, and I want that font to be size 14. So I plug all that in, I press Control Enter. The code runs, and it works correctly. The requirement is already satisfied. Next, I'm going to pull in the 5 stocks that we're going to calculate value at risk for. Apple, Google, Meta, Nvidia, and Tesla. If you wanted to do this for an entire portfolio, you could do it with an equally weighted portfolio or any weight that you want. To do that, create a variable called weights, set it equal to NumPy decimal array and 20% for each of the weights. So there's 5 arguments. Do the math, and 20% multiplied by 5 equals 100%. Create a variable called start, the start date. I'll do June 30th, 2013. That's going to be equal to Delta Tango decimal date time. And then the arguments are the year, the month, and the date. End is going to be the present, so I'll do Delta Tango decimal date time decimal now with an empty tuple, no arguments in it. Then I'll create a variable D as in Delta, F as in Foxtrot, and set that equal to Y as in Yankee, F as in Foxtrot, decimal download with several tickers. Several arguments, the tickers, the start, and the end. And then I'll have a list that's a mutable list that says adjusted close, because I want the adjusted closing prices since they adjust for dividends and stock splits, which the investor actually experiences as part of their risk-reward, profit and loss of holding these investments. And you can see the table, different dates, and the adjusted closing prices for each of the 5 companies in question. Next, I'll create a variable called prices and set it equal to D as in Delta, F as in Foxtrot. To plot that, prices decimal plot, and then I'll specify the title and I'll show it. This shows the daily adjusted closing prices. Control Enter, and this works correctly. It shows the daily adjusted closing prices from the beginning of the time period through the present for each of the 5 stocks in question. As you can see, this is an extremely misleading graph because Meta started out with a substantially higher spot price than the other stocks, so it looks like it performed better even though it did not. To adjust for this, I want the daily log adjusted closing prices, and so to do that, I'll do N as in November, P as in Papa, decimal log with the arguments prices, and I'll plot those. Control Enter, and this works correctly. You can now see it's not as clear which stock outperformed when you look at the logarithmically adjusted closing prices. this is a much more accurate graph of what actually happened and what the investor experienced over the period. Then create a variable returns equals D as in Delta, F as in Foxtrot, decimal percent underscore change, and drop the NA, which is the first adjusted closing price. We don't need that since you need 2 days to calculate a daily log return. I'll plot those returns, I'll press Control Enter, and this works correctly. You can see the daily log returns for the 5 stocks in question. With this much data, it is getting kind of fuzzy. They're on top of each other. But nonetheless, you can see there were some high flyers, both to the downside and the upside. 20% in a day, 35% in a day for some of these stocks every once in a while. So they're highly volatile, highly risky securities, and that's why we're doing value at risk. I can summarize the returns by creating a variable called returns underscore summary, setting it equal to 100 times the returns, decimal describe, with an empty non-mutable tuple as the end for describe, and then returns summary I can round it to 2 decimal places. Control Enter, and this works correctly. And you can see the average return over the time period for each of the stocks, the standard deviation for each of the stocks. You'll notice that the daily standard deviation totally overwhelms the daily log returns, and that's why it's good to benefit from time diversification by holding the stocks for longer. The longer you hold a stock, the more likely that you are to benefit from the systematic risk premium embedded in the stock. For longer time periods, the standard deviation would fall a little relative to the average return, but would still probably be higher. You can also see the minimum returns for each of the stocks in question, as well as the max. So you're seeing, NVIDIA up nearly 30%, Meta down nearly 26% for its worst day. So you can see what I'm talking about. 20, 25, 30% moves don't happen every day, but can happen with some of these high-flying tech stocks. And then you can see 25th percentile, 50th, and 75th percentile returns for each of the stocks in question. So that's a nice little summary. And then if I want to actually plot the value at risk using the historical method, I use this code that you're seeing on the screen, and I'm going to plot it for different time periods of historical daily value at risk based on 1 year of historical data, 2 years, and then 3 years. Control Enter to run this. And you can see here, this is Apple's stock returns over the 1, 2, and 3 year periods. The orange line is the 95th percentile value at risk cutoff. So in other words, we're saying in a typical day over the time period in question, we're 95% confident for the 1 year historical data that Apple's not going to lose about 3% of its capital in a single day. And then the red line is 99% VaR. So we're 99% confident that we're not going to lose more than about 5% in a day for Apple. But you can see there's still a few data points to the left of the red line. So it can and does happen. You could lose more than 5% in a day by investing in Apple. But it's 1% of the time, if that. It's not out of the question, though. And you can also see on the right tail, there's some times where you can make 5, 6, 7% in a day with Apple. But again, that's like less than 1% of the time. Then if you wanted to calculate value at risk at different intervals, daily daily VaR, monthly VaR, quarterly, and yearly VaR. You can use the code shown below with the arguments returns, 95% confident interval, so alpha equals 9 or 5, time frame equals day, or whatever time frame you want. And you can return the VaR this way. If you wanted to do VaR for the equally weighted portfolio of 5 stocks, you could create a variable called portfolio underscore VaR with similar arguments. If W's and whiskey does not sum up to 1, there should be an error that says the sum of the weights must be equal to 1. And then you can have those returns and weights, build out a correlation matrix, and then calculate the VaR that way. And then I did similar code. I copied and pasted my original code for the other 4 stocks and then just changed the ticker symbols and the title. So you can see this is what it would look like for Tesla. So we're 99% confident that we won't lose more than about 8 or 9% of our capital in Tesla in a single day. Although it's not out of the question we could. It looks like even within the last year, Tesla had a trading day where it went up almost 20%. So you could make a lot of money and lose a lot of money in these stocks. Meta has a tighter distribution, so that's kind of interesting. And then you can see here NVIDIA not as tight as Meta, but still a fairly tight distribution relative to Tesla and some of those other type stocks. And then finally, I'll show you the last one, which is Google. So that's how you calculate 1-day value at risk for the individual stocks over different historical time periods. And then again, if you wanted to, I didn't show it graphically here, but if you wanted to, you could definitely calculate this for a portfolio of these stocks. So take this knowledge into the marketplace to be a better investor, a better user of Python, and a better risk manager. Have a great day. Thank you for watching this video. Please subscribe to my YouTube channel, hit the notification bell, hit the like button, leave a comment below, and please buy my books. The links to those will be in the description of this video.